Good morning, Year 5. Today is Tuesday, the 26th of January. The learning objective for today is to relate 3D shapes to 2D nets. So when we think of the 3D shapes, that stands for three-dimensional. It's something that you can pick up and it is not flat. 2D shape, meaning two-dimensional, meaning that it is a flat shape. Okay, so today we're going to be looking at those two things. First of all, just a quick 5-minute warm-up. Question number 1, list all the factors of 15. Try and remember the factors. What is divisible by 15? Question number 2, how much warmer was it on Tuesday than Friday? So think about how much warmer, that difference in temperature. A simple subtraction, question 3, and question 4, what fraction is shaded? Also on the top right of the screen, you'll notice a Roman numeral. I wonder if you can remember what that Roman numeral represents in numbers. 5 minutes to do that task, boys and girls. Off you go. Okay, hopefully you haven't peeked at the answers on the next slide here. Let's go through them. So first one, list the factors of 15. We've got 1, 3, 5 and 15. Question number 2, how much warmer was it on Tuesday than Friday? So the temperature on Tuesday was 19 degrees and the temperature on Friday was 13. How much warmer is that? What is the difference in those temperatures? The answer is 6 degrees. Calculate 3,985, subtract 1,629. The answer was 2,356. What fraction of the rectangle is shaded? So on the denominator is how many parts altogether in the whole, and the shaded part is shown in the numerator position. So your answer is 3/8. You can always ask yourself, can this fraction be simplified? The answer is no in this case, as both the numerator and the denominator do not share a common multiple where they can be divided by. Let's take a quick glance over to the right here to the Roman numeral. C is representing the number 100, and then we have 2 i's. So your number is 102. Well done if you got those questions correct. Right, moving on to today's learning. Let's look and see if we can have a little bit of revision and some thinking time about the names of these 3D shapes. Okay, the first one here. What shape is that? The shape is a cylinder. Next one. Notice all of the 2D shapes. If we were to pull this 3D shape apart to make the net, they would all be made up of triangles. Bit of a mouthful, this one. It's called a tetrahedron, or some people call it a triangular based pyramid. Okay, tetrahedron. This time we have got, so we know it's not a tetrahedron. Prism meaning that if I was to slice through it all the way along the shape, they will represent exactly the same shape. I always try and think and show people a Toblerone at this point if we were in class. Imagine if we were to slice through that, it would be a completely same shape every time that I slice through. So this one is what we call an octahedron. Next shape. So just as what I was talking about prisms, we know it's not a cylinder. Cylinder you can roll. This one is a triangular prism. This time, if I was to unfold this 3D shape to make a net, all of the shapes would be the same, all made up of squares. So this one is a cube. I always try to think of a dice for this one. Next one. If you were to count all the sides of this shape, you would have all of the faces, sorry, you would have 10. So you've got dodecahedron. Break it up, bit of a mouthful. Dodecahedron. This one, I think you should know, a little bit of revision from previous years. Here we've got a cone. If we look at the bottom of this pyramid here, you can see it's got 1, 2, 3, 4, 4. So it's a square at the bottom, so it is a square base pyramid. I know it's quite difficult to see. It does look like a circle, but you can see a little bit of a shadow there on the right. This is what we call a sphere. Okay, this one. Think of your geography lessons. Think of your science lessons when we've been looking at the rotation of the Earth and where the light from the sun's rays. If I was to cut my world in half, I have 2 of these. Have a think. It's a hemisphere. This shape is called a cuboid. It's different from a cube because a cube is made up of squares, all the same size. Okay, this one is made up of squares and rectangles, called a cuboid. Okay, moving on to looking at nets. So 3D shapes have bases, edges and vertices. In brackets there, this just means the corners. A net shows what a 3D shape would look like if it was opened out flat. So here we have on the left hand side here, we've got, hope you can remember this shape. Well done, it's a cube. And if we were to unfold this cube, we would have the net would look like this. So we've got the vertex or the vertices, the pointy parts, the edges and the bases. So again, imagining that you are unfolding that 3D shape, what would the cone, which net would represent the cone? This shape here. If we were to fold this back up, we would have a cube. This one, and another beginning with C, we would have a cylinder. Okay, remember this one is called the octahedron, when we've got 2 square base pyramids almost stuck together at the square point. Okay, so look carefully at the 3 choices here at the bottom. Which one would represent the octahedron? So imagine in your mind's eye folding the shapes back up to make that 3D shape. It will be this one here on the right. Okay, so let's name the 3D shape first. We've got a triangular base pyramid or a tetrahedron. Here, imagine fold that first one on the left here. Imagine folding that up. What would it create? And the others as well. It will be this one. Okay, here we've got another prism. I would just like you to look at the end of the prism here on this 3D shape. How many sides have we got? We've got 1, 2, 3, 4, 5. So think about a 2D shape that has 5 sides. We've got a pentagon. Okay, so we call this a pentagonal prism. So if I was again to slice through with a pair of scissors all the way through, a lot straighter than those lines that I've just drawn there, you would have the same shape every single time. So have a think, which one would represent the net of the pentagonal prism? So look at the end parts. Which one is it? Definitely not, and which one could it be? So look, we're looking for the 5 sides. That's a big clue, okay? And it would be this middle one here. We can see the flat 2D pentagon shapes at the end there. Here we've got triangle, here we've got 6-sided, which is the hexagon. Which of the nets shown match this 3D shape? So the 3D shape here we have is a cylinder. If we were to unfold that, we would have the faces made using the 2D shape circles. So which net shows us that? It is this middle one here. Okay, so this time we've got another prism, but let's count the faces at the end of the prism so we can see what type it is. So we've got 1, 2, 3, 4, 5, 6. So you've got a hexagonal prism. So look closely at the pictures of the nets at the bottom. which face shows us that representation there, same as on the 3D shape, and it's the one on the right there. Okay, because you've got those two hexagons there unfolded. Which of the nets shown match this 3D shape? So hopefully you should know the name of this shape. It is the cuboid. Imagine it is unfolded. Which one would it be? The one on the right here. Pretty easy, that one. Okay, we have another prism here, and this time the two faces at the end of the prism are triangles. So let's think about what is at the end of these two nets here. I know it's not this net because it wouldn't fold up to make a prism, because around the prism here I've got 1, 2, 3 rectangles, flat rectangles. So I know it's not that one. Okay, so have a little think. Which net would represent this shape here, this 3D shape? And it's the one on the right there. Oh, I think you can spot this one straight away. Here we've got the cube. It's this one here on the left. Okay, again, thinking logically. We know we've got a pyramid. It's a 1, 2, 3, 4. There's a flat square at the bottom, so we've got a square base pyramid. So looking at the central part, what would give me the base of this pyramid? I know it's not that one. That wouldn't fold back up together. So which one would it be? Imagine folding the sides up. It would be this middle one here. Untrue nets. A 2D shaped net must accurately represent the unfolded 3D shape. The faces of the 3D shape must be in the correct position. These are untrue shape nets for a cube. So this one here on the left, we couldn't fold. If we were to fold this up, it wouldn't make the cube here in the middle. The same as this one here, there will be gaps in that 3D shape. So they're what we call untrue nets. They're false. So looking at this net here on the left hand side, why is this an untrue net? So imagine folding that up. We've got a bit of a problem here. We've got something missing down this end. What needs to be changed to make this correct? So as you can see, we've taken that triangle from the position where it was here and popped it at the end. So now when we fold it up, the 3D shape is complete. It's a true net. There are no gaps anywhere. Again, we've got another example. Why is this an untrue net? So for this to fold up on the left here, the square folding up, I would also need another square on this side. But for some reason, the other square is far at this end. What needs to happen for this to be correct? So we've moved the rectangle, which was positioned here, down onto here. So this almost becomes the top of the cube, cuboid, this part of it. Okay, so you really imagine it folding it up. Okay, your task for today will be on a Word document if you are using Teams. So you will be able to show me your answers on there, or you can take a picture of your answers, maybe try drawing some of them as accurately as you can if you are drawing them in your maths learning journal at home. Okay, good luck boys and girls, well done.